Welcome to this webinar on how to achieve automation at scale with CircleCI and AWS. My name is Aaron Stillwell. I'm a solutions engineer here at CircleCI. So my background is in building software, but my role here at CircleCI is to work alongside our European customers in order for them to get the most out of CI/CD on the Circle platform. I also want to introduce my partners and colleagues on the call today. We've got Dara and Zan. Guys, do you want to introduce yourselves?
Hi, my name is Dara Flanagan. I'm a partner solution architect with AWS, working with growth partners in the EMEA region. And I've been with AWS for about 18 months now. And yeah.
Hi, my name is Zan Markin. I'm a developer advocate at CircleCI. I joined very recently, and my focus is working with developer communities in the EMEA region in particular. Today, I will also be helping out with any Q&A. I won't be presenting, but I'll help pass any of your questions to Aaron and Dara. If you do have any questions throughout the event, please use the Q&A feature of Zoom.
Perfect. Thanks, guys. So today, if we want to just move to the next slide, we're going to be, first of all, hearing from Dara on Amazon's story and some of their digital transformation stuff and some of the work they've been doing across Europe. We're then going to be looking at CircleCI. So I'm going to give everyone an introduction into who we are at CircleCI, what we do, where we come from, and ultimately how the platform works. But we're also going to be looking at how we can leverage our integrations with AWS in order to accelerate throughput with building and deploying on top of AWS. So we're going to be looking at that a little bit later on. But I want to kick off by handing over to Dara to talk about AWS. Dara?
Thanks, Aaron. At AWS, we provide customers with the broadest and deepest cloud platform. AWS has more services and capabilities within each service than any other cloud provider. With AWS, customers get the right tools for the job they want to get done. We deliver innovation to customers at the fastest pace. In 2011, we released over 18 new significant services features, followed by 160 in 2012, 280 in 2013, and doubling almost every year until 2018, we released nearly 2,000 new services and features. We have the most mature cloud platform. There's no compression algorithm for experience, they say, especially when it comes to scale, security, and performance. So how did we get there? When we started out, this is what Amazon's web architecture looked like. It's definitely nothing too fancy. This is a web server with a database hosted in a remote facility. And of course, this design presents many different bottlenecks, and scaling the web server is an immediate challenge. If we move forward to around 1998, we began to break things down into separate components. To scale the web server, we improved the original design by adding web databases to alleviate the bottleneck of accessing a single database. This design is clearly better, but it's still not very scalable and presents a different set of challenges. To go further, we knew we had to change. So we came up with 4 principles that would help us transform into the company we are today. First is to make units as small as possible. It's easier to reason about the impact of changes when systems are small. Large and complex systems are inherently problematic to changes, and it's nearly impossible to map out all of the dependencies and interdependencies that exist. Second, we decouple based on scaling factors and not functions. What this means is to think about the different factors that affect scaling. So when thinking of a 3-tier application, it's almost natural to think about decoupling each different tier. but you would fall into the trap of decoupling based on functions such as the web layer, the application layer, and the database layer. If you decouple based on scaling factors, that means that we might decouple the three-tier application into services such as authentication, identity, shopping cart, storefront, or order processing. And this allows us to scale each service based on the usage of the service and not the function of the components. The third is that each service operates independently. And this means that there's no release schedule and no other service to encumber deployments of features and functionality. The fourth is we develop APIs between services. And this principle enables the other three services by having services expose themselves via an API. APIs add a layer of abstraction, and one service consuming resources from another does not need to be concerned about the implementation details. This meant we needed to get reorganized, and it led to the development of what we call a two-pizza team. A two-pizza team is one in which each team is made up of no more people than can be fed by two pizzas. This keeps team sizes small enough to not impact communications, but also forces teams to be creative in how they deal with scale and the service that they operate. At AWS, our two pizza teams are autonomous to make decisions and work directly with customers. They are empowered to develop and launch based on what they learn from interactions with customers. We iterate products continuously, and the newest and latest is instantly available to customers. There's no need to upgrade, deploy, or migrate. When a feature or enhancement is ready, we simply push it out and it's instantly available to customers that use that service. What you'll see on this slide is a typical monolith development lifecycle. Large team of developers, a single large monolith service, and a single delivery pipeline. There are a lot of different bottlenecks here. Developers have to pay attention to the details of the implementation to avoid impacting the service. This usually means a lot of meetings to discuss the change, lots of testing to ensure no other components break due to changes, and a single threaded delivery pipeline that are on a release schedule. All in all, you have a really slow and fragile software delivery lifecycle. So now we have the changes necessary for the four principles that we mentioned earlier. First, we break the developers down into two pizza teams. Next, we break the services down based on scaling factors, or what we call monolithic services. Then we give each team their own individual delivery pipeline so that they can release at their own pace and not have to be encumbered by the release cycles of other services. This developmental shift has had a positive impact on our ability to innovate at high speeds and at scale. Fast forward to today, and this is a picture of the different microservices at AWS and how they're interconnected. So the four principles, the two pizza teams, and the development-enabled pipelines is part of what allowed AWS to scale to build more services and more features within those services than any other cloud provider. There are 5 reasons that companies are moving so quickly to the AWS cloud. The first is agility. AWS lets customers quickly spin up resources as they need them, deploying hundreds or even thousands of servers in minutes. This means they can very quickly develop and roll out new applications, and it means teams can experiment and innovate more quickly and frequently. If an experiment fails, you can always deprovision any servers without risk. The second is cost savings. If you look at how people end up moving to the cloud, almost always the conversation starter ends up being cost. AWS allows customers to trade capital expense for variable expense, paying for IT as they consume it. And that variable expense is much lower than what customers could do for themselves because of AWS economies of scale. For example, Dow Jones has estimated that migrating its data centers to AWS will contribute to a global savings of 100 million in infrastructure costs. The third reason is elasticity. Customers used to over-provision to ensure they had enough capacity to handle their business operations at the peak level of activity. Now they can provision the amount of resources that they actually need, knowing they can instantly scale up or down along with the needs of their business. And this also reduces costs and improves the customer's ability to meet their user demands. The fourth reason is that the cloud allows customers to innovate faster because they can focus their highly available IT resources on developing applications that differentiate their business and transform customer experiences, instead of the undifferentiated heavy lifting of managing infrastructure and data centers. The fifth reason is that AWS allows customers to go globally in minutes. AWS has the concept of a region, which is a physical location around the world where we cluster data centers. We call each group of logical data centers an availability zone, and using AWS, customers can leverage 73 availability zones across 23 geographic regions worldwide, and it's not going to stop there. As mentioned earlier, this is only an abbreviated history of Amazon and AWS. If you want to learn more, you should check out the Amazon Builders Library, which is a collection of living articles and videos that gives readers a look under the hood at how Amazon builds and operates the technologies that underpin Amazon.com and AWS. The Builders Library content is written by senior technical executives and engineers who are responsible for that topic on a daily basis, and provides a deep dive into real-world practices used at Amazon every day. Also check out our AWS modernization workshops. At awsworkshop.io, you'll find a collection of workshops that cover basics and topics around modernization. The workshops provide hands-on approach to modernizing various aspects of your business and what technology will drive that change. We're also running a 2-day modernization workshop in November. This is aimed at ISVs looking to deploy their application using a scalable self-healing architecture on AWS, November 17 and November 18. And there's a link on the slide here, which I'll provide after this session. And with that, I'll hand over to you, Aaron.
Perfect. Thanks a lot, Dara. Just gonna share my screen with everyone. Dara, can you see my screen?
I can indeed.
Perfect. Cool. Thanks a lot, Dara. So with that intro, today we're going to be looking at, first and foremost, for those of you who maybe are looking at AWS, but maybe not quite sure how CircleCI fits in or really what we do or where we come from, we're going to be giving a brief introduction into the CircleCI platform and ultimately how it works, how you leverage it, and so forth. We're then going to dive straight into some of the nuances around how we configure CircleCI, specifically some of our reusable configuration syntax that allows us to sort of dry up CI/CD configurations. And that really sets the basis for how we then integrate with third parties such as AWS within our CI/CD pipelines. We're going to be doing that while we look briefly at a fairly simple project on CircleCI that I've prepared for today's session, where we build, test, and then deploy a Docker image to AWS ECR. Once we've looked at those kind of orbs and configuration, we'll then dive back into that project to look specifically at how we integrate with AWS within that project. And then when we wrap up today, we're going to be just finishing with a sneak preview into one of the features that we're currently running in beta, which allows our customers to run deployments behind the firewall in the context of their own AWS account. So with that, this should probably take, I'm expecting, sort of 20 minutes, 25 minutes, and then we'll get into some Q&A that Zan is going to run for us. So to introduce CircleCI, our reason for being is really to take you from idea to delivery in the shortest possible time frame. So at CircleCI, we were founded back in 2011 as one of the earlier sort of pioneers of the YAML configuration as code approach to CI/CD that has now become fairly prominent within the space. We're now doing over I believe, 50 million builds per month, at least, on our cloud hosted, fully managed CI/CD platform. And we're doing this across some of the largest engineering organizations on the planet, including folks like Facebook, Spotify, Segment, you name it. Just a few of those logos presented here. So where we sit really in the tool chain is firmly between wherever your code lives and where it runs. So what we see here is your VCS on the left-hand side, namely GitHub and Bitbucket is what we support today, with more to come. And on the right-hand side, we've got wherever you're running and operating your code in production. So in this case, we're firmly looking at AWS, but ultimately it could be running anywhere. And what we're seeing more and more today is it will be AWS in one place, but it might be, still bare metal or legacy somewhere else. We try and integrate really seamlessly with wherever that code is deployed. But one of the trends we're seeing more and more is there's much more automation going into everything between these 2 points, rather than simply the traditional build, test, and deploy. We're seeing more and more things like security scanning that goes on within that process, scanning your dependencies, scanning containers with vulnerabilities, and so forth. We're seeing automation that integrates with your project management software as well, ultimately ensuring that from commit to deploy, you're really eliminating any inefficiencies and maximizing throughputs. So I'm going to jump out of my deck here and into the project that we're going to be looking at today. It's a pretty simple project. There's really not too much going on here from an implementation point of view that I want to focus on, but rather the patterns that I use as part of this project to build, test, and potentially deploy. So at CircleCI, when you come to use the platform for the first time, you'll be asked to log in with your VCS provider, either GitHub or Bitbucket today. And when you've logged in, you can add on a per repository basis the projects that you want to begin building. When we've gone through that process, we can then begin configuring CircleCI. And as I alluded to earlier on, we do that through this YAML-based configuration as code approach to CI/CD that we really pioneered almost 10 years ago now. So you'll see here in our repository, we've got a config.yml file, and it's actually this YAML file that I have open on the right-hand side of my screen here in VS Code. So we're going to be walking through this YAML as we look at my particular project. If I switch tabs very quickly, you're going to see here that I've got a workflow that's being shown in front of us. And a workflow is simply a acyclic graph that shows us the relationships between all the different jobs we want to run when we commit code to when we deploy it. So this is where all the automation takes place. This particular workflow is being configured in my YAML file on the right-hand side of my screen. So you'll see I've created a workflow under the workflow stanza called build and test. We specify some jobs that we want to run within this workflow, and then we give each job a name, and we can actually tell CircleCI in which order these jobs should run by using that requires key. So each of these jobs that we see here within the workflow graph specifies and uses its own execution environment. So we actually have 4 that we can pick from today. We have the traditional Linux VM based approach that many of you are probably familiar with. That is where you're given a VM that you have root access to, that you can install anything you want on, for example, the AWS CLI to do some automation with AWS. We also have Mac-based VMs and Windows-based VMs, but our most popular approach now to running these jobs in your workflow is a Docker-based approach, where actually you specify a Docker image that could be living on Docker Hub. It could also be in ECR on AWS. It could also be in any private Docker registry. And we'll actually pull that image and spin up a container for you to run this particular job. So there's no operations involved. There's no having to worry about managing any of the machines behind this. And there's really no limit to how far you scale. So we have, you'll see here in this workflow, 2 jobs that run at the same time. There's no limit to how many jobs you might be running at once. And we're looking to ultimately deliver maximum throughput. So you never have developers waiting around for things to provision or for long test suites to run. So let's jump into one of these jobs where I'm building a Docker image. We'll be coming to some of the AWS specific pieces in a short while. But if we expand this job stanza in my YAML, you'll see we specify the job name build, and we're actually specifying simply a Docker image that we would like to use as the basis for this job. So CircleCI pulls this image from Docker Hub, spins up the container, and then we're going to run through a sequence of what we call steps within the container. A step is ultimately anything you can run in a container or a VM. You could be installing the AWS CLI and using that. You could be running your tests. Hypothetically, you can be mining Bitcoin, but please don't do that. But ultimately, this is just a compute engine. And behind that compute engine, we can also control how much compute we have available to each of these jobs. So you'll see here within the UI, we have 2 CPUs and 4 gigabytes of RAM available to this container, but we could control that fairly easily through our YAML. If I added this resource stanza here, I could specify the 2x large plus resource class, and of course that would actually give us 20 CPUs and 40 gigs of RAM if we were doing something particularly compute intensive within our workflow. Jumping back very quickly, you can then imagine that we actually can combine Linux VMs, container-based jobs, Mac and Windows-based jobs, all within the same workflow. And each of these jobs can actually select independently how much compute of that resource class you want to use. So you can really mix and match throughout the entire workflow. Further in here, we have things like the ability to debug with SSH built into the platform. You'll see that lives simply under this rerun button. So although CircleCI is managing and orchestrating all this compute on your behalf, you still have all the access you need to be able to effectively debug problems and understand what's going on without being constrained. And before we go any further, I want to jump back into some of the more advanced configuration syntax that exists within this YAML file so that we can then jump into how we might integrate with AWS. But just to recap, so we've got that ability to orchestrate workflows, and within that workflows, we have jobs, and each job can specify how much more or less compute you need. If it is a simple AWS deployment, we might just select 1 CPU, 2 gigs of RAM. If we're running some enormous test suite, it may be the case that we want to really scale up that compute on demand. And a feature we have within here when we start to talk about deployments in particular is the ability to store secrets within CircleCI so that while we're automating all the different bits and pieces we want to happen between commit to deploy, we can successfully authenticate with third-party services. So CircleCI includes secrets management, and we have a concept called contexts that enables you to actually store your secrets securely in CircleCI. We use HashiCorp Vault behind the scenes for this. And you can automate the storing and setup and rotation of these contexts through our API as well as command line tool. If we look very quickly at my own project, you'll see here each of these jobs actually requests access to a context. And a context is a grouping of those credentials. So this job here within my workflow, the build job, requests access to the AWS context. And in that context, we have our AWS secret access key and access key ID. Those credentials are then exposed as environment variables. So if we jump into my job here on the left-hand side of my screen, you'll see we actually have the access key and secret access key. We'll come a bit more to how we can secure deployments a little bit later on. But before we do so, I just want to jump into how we can, once we've started building out this automation, ensure that we're reusing some of this YAML across our project or even projects with some of this reusable syntax. So as we just mentioned, we've got a workflow. That workflow consists of jobs, and ultimately a job does two things. It specifies the compute that is required, as well as the steps that you want to run on that compute. Our YAML-based syntax exposes these by job definitions, which we see here. But whereas in my own project, you'll see we specify in line the Docker image, or it could be the VM image, as well as the steps we want to run, we can actually extract those out into their own stanzas. So you'll see here, we actually have a commands stanza. We can actually write our own command that is an amalgamation of different steps that we want to run within a container. So we could build our own command, for example, that might authenticate with AWS or install the command line tool. So we build a command, and we can actually provide parameters to a command so that we can reuse them across multiple jobs, but actually specify within each job a different parameter. For example, we might have one job that uses one AWS profile, another job that uses another, and they can both use the same command. When we use a command, you'll see in this job at the bottom of my screen here, we specify the steps, and we can simply give the command name like so. And that command name will essentially be expanded into the steps we see in the command definition. We can also extrapolate the execution environment itself. So that's what we see here within this executors stanza. So if we have maybe 10 jobs within our workflow and they all use the same Docker image, we don't have to keep rewriting that Docker stanza time and time again. We can simply specify this once in the executor stanza. We specify the Docker image or the VM settings. We could also bundle this with a resource class option. We could also add some environment variables that we want to expose at runtime. And again, we can parameterize these executors as well. So we might have multiple jobs that use the same executor, but just with a different Docker image tag. So we can actually have the tag specified as a parameter here with a default, and then we can actually use that tag like so when we specify the Docker image. So we can be quite clever about drying up our YAML-based syntax and then reusing it within our project. Now, these concepts are what ultimately lay the foundation for our integrations with third-party services such as AWS. At CircleCI, we have this notion of an orb, which is ultimately a package of CI/CD configuration. It's also written in YAML. And these packages expose commands, executors, as well as jobs that you can then bring in to your configuration without having to reinvent the wheel time and time again. So if we see here, we look at a very trivial example orb. An orb, once again, is just built up of commands. We have executors, and then we have jobs, which simply combines the two. So this allows us to then, when we define our own workflow, perhaps we want to build an image for ECR and publish it to ECR, we can just specify in our workflow the name of the ECR job from the orb, rather than actually have to think about, well, what execution environment do we need? What compute do we need? What are the steps I have to write in order to authenticate with AWS and push an image? We've got a number of different orbs available that are specific to AWS now, that we've partnered with AWS to provide. We have the bare bones CLI orb that will automate for you the installation of the CLI so that you can just focus on writing whatever CLI instructions you need to leverage as part of your CI/CD process. We also have orbs for ECR, S3, ECS, EKS, code deploy, as well as the SAM serverless model. All of these are available on our developer hub, so you can actually go away and search for these orbs after today's webinar, and you'll see that the YAML-based configuration for each of these orbs is totally in the open. It's all on GitHub, so that you can also just, if you want, fork these and customize them as you wish. So let's jump back into my project and look a little more at the specifics as to what's going on and how we are building and testing our Docker image to deploy to ECR. So coming back to my workflow, we have a first job here that I've called build. And within this particular job, we are building the Docker image, and we're actually going to push it to ECR. So if we jump into this particular job, and I expand the YAML on the right-hand side of our window here, we first of all specify a CircleCI base image that has only sort of the minimum kind of dependencies available to us. You'll see I haven't actually specified a resource class, so this job will run in the default Docker medium executor. And then we've only got 4 lines of YAML within this job when we define our steps. The first section here is actually specific to CircleCI that allows us to spin up what we call a remote Docker environment. I won't go too much into the specifics around this feature, but it's essentially what allows us to build Docker images from within a container-based job. So it's the Docker in Docker paradigm. So we're still benefiting from the really fast spin-up of a Docker-based CI/CD job, but we can still build and publish images from within that job. So enable that remote Docker environment. And you'll see here within our configuration, we have ECR/build and push image. So at the top of my YAML-based configuration here, we have some orbs that are being specified. We're using the AWS in ECR orbs. So we specify AWS, and that could actually be any sort of namespace that I want to reference back to the AWS CLI orb from within my configuration. We specify the fully qualified orb name pinned to a particular version. And this is important because once a package is deployed to our registry, it can never be changed under a given version name. Why? Because we don't want you to suffer from non-determinism where you run a commit one day, everything's green, you deploy to production, and the next day some orb version has changed and therefore your CI/CD pipeline is broken. So if you pin this to a particular version, you have the confidence it will never change. So we've got the ECR and the AWS CLI orbs ready to go. And back to our job, we then specify the namespace we set up here, ECR. We actually reach into that job, that orb, and we run the build and push image command. So I'm actually going to just open up in a separate tab the documentation for our ECR orb. And you'll see on this page here, we have the name of the orb here with the particular version, the latest version available. We can see when it was published, how many releases we have, and so forth. And we have a quick start guide to give you an idea of how you can start using this orb. But if we look to the left-hand side of my screen, we then have the different jobs, commands, and executors that are exposed by this particular orb. So let's look at the commands here. I'm using the build and push image command. So let's have a look at this particular command. And what we'll actually be able to see are all the parameters that are actually exposed by this given command, as well as all the individual steps that this command will then run within our container or VM. So we have really full, transparent access to what this orb is doing, as well as some very clean documentation on the different parameters that we can provide to this command. If we jump back into the project, we can then actually see that despite this job only having specified 4 lines of steps here, we actually see a much greater number of steps within the job itself. You'll see the AWS credentials are being configured, the region is configured, we log into AWS ECR, and then we build the image, and then we push it to ECR. All of that is accomplished with essentially these 3 lines that are being expanded to that full set of steps. Now, we're specifying as a parameter the repo that I want to push this image to, but we're also specifying the tag that I want to tag this image with. And what we're doing here is we're actually using some special CircleCI syntax for leveraging what we call pipeline parameters. And these parameters expose some information about the particular build. So you'll see here we have the Git branch that's coming from GitHub. We also have a pipeline ID, which is a unique ID for this particular run. And we're actually concatenating these two values together with a hyphen, and that's what we're going to use as the tag for this particular image. So every time we run this workflow, we'll have a new image corresponding to the workflow run. Once we've this job is successfully completed and we've pushed this image to ECR, the next job in our workflow, the test job, is going to do something I think is quite interesting. Because what we do here is we're actually going to spin up a container-based job, but the image we're using for this container-based job is the image we created in the previous job. So you'll see here in my test job on the right-hand side, we specify the executor. So I've actually extrapolated my definition for this executor into some of that reusable configuration we looked at a few moments ago. We can provide a parameter if we wish, but the Docker syntax here is then being provided by this particular piece of reusable config, and the image is pointing to my image on ECR. And again, we're using that parameter to then define which tag we're going to pull. So we spin up an environment, and you'll see here the image that we're pulling is actually going to be the same one we created in the previous job as part of the same workflow. So here we're actually going to test the image that we just built. Once we've spun up the image or the container, we can then simply run whatever steps we want within this container that is being pulled from AWS. Of course, this image is privately hosted on ECR, so no one else can access it. And again, if we look at my workflow definition, it's because we're specifying the AWS context that we actually have access to our AWS access key ID and secret access key, so that we actually have access to that image. There's a few other best practices around here when you're following this sort of pattern, namely our Docker-based jobs actually run within AWS in the US East 1 region. So if you're going to build your own image and push it to ECR and then pull it back within the same workflow, if you use a US East 1 region on AWS, you actually benefit from being within the same region as our builders. But what's more, you can actually improve the speed up and spin up of this particular job if you build your Docker image from CircleCI's own images. So you'll see here in my Docker file, I use the CImage namespace, which is one that CircleCI owns and publishes to. And the reason I'm doing this is because a lot of the layers that form this image are cached across our Docker build machines because they're being used by lots of different customers. So if we use those same layers, a lot of the image will be cached, and then we can just install whatever we want on top to ensure we have a really customizable execution environment for the job. Before we wrap up and look quickly to the future, I'll also just point out, as part of this demo, we do have a job that also installs the AWS CLI. Again, very much the same principle. This particular job, defined on the right-hand side, specifies an executor and then a sequence of steps. And again, here we are running the AWS/setup command, which expands to all these different steps here that installs and configures the CLI. And then of course, we can just tack on any AWS commands we wish here, knowing that the CLI is going to be authenticated and ready for us to use. We don't have to think about how we actually want to kind of install and prepare that environment. So to the future, one of the popular requests we get when we're working with AWS is, well, it's okay that we have this context mechanism when we can rotate programmatically the contexts and how they live in CircleCI. But what we really want to be able to do is within that workflow, perhaps just run the deployment job within our own environment. So we don't have to worry about all the operations of running, our own CI/CD tool for building and testing our project. We just want to have maybe one EC2 or Lightsail instance that exists in our own VPC just for deployment. So we have to still manage something, but it's very much limited to only the bare minimum. So what we're doing at the moment is we've currently got a private beta running with a select few customers that actually have access to a runner that they can install on their own machines, on their own AWS or private cloud account. And the way this works, as we'll see here, is we actually have the ability to specify our own resource classes. So when we looked at our demo previously, we can specify the resource class to say how much CPU or compute do we want within CircleCI's cloud. Or with our runner, you're going to be able to create your own, but you control where that runner is actually living and what that resource class actually means. So you'll see here the change would be, we've got our test job, we're still going to use the CircleCI cloud, we're still going to use the Docker-based approach, we're still going to have all the flexibility of CircleCI's compute. And then with our deploy job, in the exact same workflow, we're then going to move to using our own machine just for deployment. And so we can use our own IAM profiles and our own VPC for the deployment. And if we look at how that changes the UI, you'll see here, as per the demo earlier, we can see in the job view how much compute we have available. But that's all running within the Circle network and all managed on our behalf. But then when we use our own resource class, you'll see here that's denoted as such. So Aaron Stillwell that's my name, that's my namespace that I've created. And AWS is just an arbitrary name that I've given my own runner. I've installed that on a Lightsail instance in my own AWS account. You could create whatever naming conventions you like for your own runner. So that's coming in the future. If you would like access to this at the moment, I would recommend that you speak to, if you have one, an AWS, CircleCI representative for your account to start that conversation with us. But with that, I think we're just about at time and hopefully ready to take on a little bit of Q&A. Sam?
Hello. Yeah, so we've got a few questions already. If you obviously have any more during the next few minutes, please do ask. Are there any plans to allow workflows within authored orbs?
Good question. So I don't know of any plans to expose workflows as part of an orb at the moment. Something I'm very much happy to take back to our product team. But what I would recommend, if you haven't already, is post this recommendation, if it doesn't already exist, on our ideas portal, which I think is ideas.circleci.com. We've recently revamped that whole product request platform on CircleCI.com. It did get a little bit stale over the past sort of year, but we've totally revamped that, and we are tracking and we are active on that board. So definitely check that out, post it there, and I'll see if there's anything I can learn internally about our plans for additional components to orbs.
Okay, next one. Does CircleCI have support for caching of Docker layers?
Yes, so I didn't talk about that too much within my demonstration there, but yes, that is a native part of CircleCI. There's a flag within my project in the YAML that allows us to essentially seamlessly tell CircleCI to cache the layers when we build our own image. So yes, if you search our documentation, you'll find more information on exactly how that works and how you can leverage it.
Okay. How many jobs can be run at one time?
So as I alluded to a little bit when we looked at our workflow there isn't any sort of hard limits on how much compute you use. You're not bound by any solid numbers in terms of concurrency. We look to ultimately enable throughput at scale. So again, some of our large customers who are using CircleCI are running at any given time thousands of jobs, and we want to really unlock that level of throughput. And as per the runner conversation towards the end there, what we're doing there is enabling you to make sure that you have that scalability accessible where you need it, and then only leverage your own kind of VPC or your own compute where it's really necessary, where the cloud can't fulfill your requirements.
Okay, one more just came in. So we use CircleCI in production, and we have multiple workflows. We use Terraform to provision our infrastructure. That code resides in a different repo. What are your thoughts for the best way to trigger workflows in different repos?
So one possibility is through the API. So we do have some documentation on how to trigger a build on a different repository through the API, and using pipeline parameters, you can actually control when a particular workflow will run depending on some parameters you provide through the API. So if that particular project has a workflow that you don't want to run on every commit, you only want to run when you actually run an API call from repository A, should we say, you can actually have an API call that will trigger the build, but you can turn on and off the different workflow runs through the API. If you search our documentation for pipeline parameters, you should get some good docs that start to illustrate that concept. But another possible technique here is you might want to actually just check out the second project to a job within your main sort of workflow run. So you check out the code from VCS, and then use that second repository in the same workflow. For that, you would need to look at some syntax called add SSH keys that allow you to access many more projects, and also have write access, if you wish, to different VCS projects within the same workflow. So just search the docs for add SSH keys if you want to go through that route.
Cool. And how do you handle deploying to staging or development environments?
Good question. So we have some different syntax around being able to filter what the workflow looks like depending on the branch or the tag that's been provided. And you can use patterns to actually, regular expressions essentially, to differentiate what the workflow looks like depending on the branch. A lot of people go that route, but also, again, you can parameterize those jobs. So you might have a deployment job, but then in your workflow, you call the deployment job, but you provide the parameter environment production or environment staging, and then filter those jobs to only activate on the necessary triggers. So the necessary branch or tag or what have you. And you can even be more complex about that with some of the API stuff I mentioned in answering the previous question.
I think that's all we have so far.
Apologies, Dara, I've sort of stolen the Q&A limelight from you there.
That's cool. I guess there might be questions for AWS. Maybe I'd just take a last opportunity to plug the 2-day modernization workshop that we're doing on November 17 and 18. I don't have the list of participants, but I'm going to drop a URL in here, and hopefully that pops up. At that URL, you'll see the list of services and get an explanation of what the workshop is all about. And hopefully it's of interest to this group.
Perfect. Cool. Well, unless there's any more Q&A, I just want to thank you, Dara, for coming along today and talking about AWS, as well as you, Zan, for orchestrating the Q&A there as well. And thanks everyone for dialing in and spending some of your Tuesday morning with us today.
Thank you.
Cool. Thanks a lot, everyone.